Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good evening to all my panelists. My name is Nur Syukriah Binti and my supervisor is Dr. Nurazua binti Muhammad Yusop. Now, I would like to present my final year project 1 with the title A System Dynamic Approach for Design for Tire Remanufacturing. Remanufacturing has been gaining popularity as an emerging sector because of its contribution to the growth of green manufacturing industry. So, what is the meaning of remanufacturing? According to Lee and others 2017, remanufacturing is the set of processes that end-of-life product and parts to be recommercialized as the new product by disassembling, cleaning, inspecting, repairing, replacing, and reassembling. Kim 2011 reported that remanufacturing offers new opportunities for remanufactured products of the same quality and value as the new product, but at the lower cost to the consumers. This may have a beneficial impact on price stability. However, in Malaysia, remanufacturing is something new to the manufacturing industry. There are many benefits if the automotive industry in Malaysia implement the remanufacturing. Thus, the study main purpose is to identify design for remanufacturing element variable and desired value that leads to the sustainability of the environment. The problem statement of this study is tires with a global capacity of 800 million units are among the manufactured products that generate the most solid waste. Tires that have been worn or used are one of the most common and hazardous waste sources because of their large size and volume. Previously, most of the industrial waste such as used tire was considered unusable. Millions of tires are recycled, thrown away or buried every year around the world, creating a great environmental threat. Furthermore, by dumping chemicals and toxins into local soil, groundwaters and waterways, illegal tire dumping poses a serious threat to public health. Objectives of this study are first, to identify the concept of car tire remanufacturing in the automotive industry. Second, to evaluate design for remanufacturing element variable and their desired value that lead to the sustainability. And lastly, to propose modeling simulation of car tire remanufacturing system model by using Sim software. The scope of this project is to study the Implement Life Cycle Assessment (LCA) to evaluate design for remanufacturing element variable and their desired value that lead to the sustainability in automotive industry. Next, energy, environment, and economic are the important element variable and their desired value that lead to the sustainability in automotive industry. And lastly, modeling simulation using software will be applied to evaluate the performance of real systems for the remanufacturing of the car tires. From the graph of articles and journal papers in the slide, we can conclude that the increasing from year to year of the distribution journal paper and article all over the country prove the awareness among the industry players toward the remanufacturing tire become increased. This graph also indicates that the industry player is interested in tire remanufacturing, resulting the study is being conducted to understand it better about tire remanufacturing. From the most articles and journals that have been researched, the industry player attracted to the tire remanufacturing due to their sustainable benefits. According to Bazan and others 2015, tire remanufacturing are the most sustainable recovery alternative compared to the other processes. Tire remanufactured product also more sustainable than manufactured tire product because tire remanufacturing is most beneficial in terms of energy, environment, and economic aspect, which the aspect could lead to the sustainable development. Next, the concept of remanufacturing, which is a key strategy for achieving sustainable manufacturing. A scientific concept of remanufacturing was established by Ijoma and others 2010 by differentiating the performance between the remanufacturing process and other processes recovery. According to Ijomah and others 2010, remanufactured is the method that restores the end-of-life product or the product used to a satisfactory performance condition below the original OEM specification. Its warranty is only given to the major worn parts. Remanufacturing also is the only method that restores the end-of-life product output to at least to the OEM specification and given the new produced product an equal warranty. Next, system dynamic approach was used for modeling simulation of car tire remanufacturing system model. Charlie and others 2019 reported that the system dynamic is a methodology for using computer simulation software to analyze complex systems and problems over time. It involves a few steps such as drawing a loop, connecting the variables, and determining the relationship between them, direct or inverse. According to Charlie and others 2019 also, system dynamics is used to inform the decision-making process in the remanufacturing automotive parts. The mostly used software tools in system dynamics include Ventana Simulation, which is VenSim, System Thinking for Education and Research, Stella, and PowerSim. In this study, VenSim software is used as system dynamic approach for car tire remanufacturing because VenSim provides free software called Personal Learning Edition (PLE) for new learners who want to get started with the VenSim. According to Jones 2014, the advanced version of VenSim provides more powerful tools for model quality control, including reality checks, data handling, calibration, simultaneous equation solving, and other advanced numerical methods. VenSim also allows the user to create a model based on the needs of the client and verify that it needs to fulfill those needs in the building process, which is uncommon for other software. The flowchart of my project started from the problem statement of the study to evaluate the design of remanufacturing element variable and the design values that lead to the sustainability. I use life cycle assessment (LCA) as the methodology. LCA start with goal and definition, then life cycle inventory analysis, life cycle impact assessments, and life cycle interpretation. To propose modeling simulation of car tire remanufacturing system model, I am using VenSim software as the methodology. This modeling simulation start with identify issue and objective, developing causal loop diagram, developing stock and flow diagram, and lastly validation of results. Then these three methods will undergo result analysis to get the result of the study. After getting the result, the conclusion and recommendation will be met. LCA is used for the study to evaluate and compare product development process for newly manufactured product and remanufactured product, document environmental impact on society, and give a stable platform for environmental monitoring. To conduct the LCA, we need to know the goal and the scope definition. For this study, the goal is to evaluate the design for remanufacturing element variable and their desired value that lead to the sustainability in the automotive industry. It involves a series of steps, including the formulation of the analysis purpose, the definition of a product system and its functional unit, and definition of the system boundaries. The second phase of the LCA is life cycle inventory (LCI). It includes the collection and quantification of output and input for a given product system throughout its life cycle, with the input and output given to each unit process individually. Input are divided into two categories, which is natural and input technological, material, fuels, electricity and heat. All emission, which is radiation and noise to air, water and land, waste and non-material emission are included in the output. The third phase of LCA is Life Cycle Impact Assessment, LCIA. For this study, which is remanufacturing car tire, the life cycle impact assessment for these three elements, which is energy, environment, and economy, needs to be done. Energy, environment, and economy is the element variable and their desired value that lead to the car tire remanufacturing to sustainability. As compared to the new product, the energy used in the remanufacturing process can be decreased by a lot of amounts. Equation 1 in the slide is the formula for calculating the energy consumption coefficient, and the equation 2 can be used to calculate the energy consumption in the manufacturing process. Next, the method for environment aspect is ELCA theory. ELCA is the environmental life cycle assessment. The LCA theory is a set of environmental impact index standards developed by comparing the original collection of life cycle inventory data, classifying and characterizing mechanical equipment used in manufacturing and remanufacturing using a list-based analysis process, and calculating energy consumption. Life cycle costing, LCC, is an economic evaluation method for the life cycle of the remanufactured product. It can calculate the cost of the product whole life cycle and predict the price for remanufactured products. Fixed cost, environmental cost, and potential cost are the three categories of LCC. The last step in the LCA process is to interpret the life cycle. It should enable for the assessment of outcome for consistency and completeness, the analysis of achieved findings of soundness and robustness, and the formulation of conclusion and remediation of reducing environmental impact. And the modeling simulation by ranking software. The most important part of modeling is determining the objective and issue to be studied, as they will lead to the building of the desired model. The objective of this study is to propose modeling simulation of car tire remanufacturing system model. Thus, the process of tire remanufacturing is identified and then presented in casual load diagram. Next, developing casual load diagram. The main function of casual load diagram is to relate any site or subsystem that will give rise. Casual load diagram get their derived from the fact that each link has a casual interpretation. An arrow pointing from A to B to indicate that A is the cause by B. Casual load diagram can help in the understanding and communication of complex structure. After that, developing stock and flow diagram. The relationship between all variables in the model can then be used to model stock and flow. First and foremost of developing stock and flow diagram, the model backbone is created so that the model objectives may be defined. Other variables will be added to the backbone to complete the functional model. Stock and flow depicts the structure of the system in the significant detail than the casual load diagram. The final step in the modeling process is to validate the model by comparing the results to the actual data. Then model result is evaluated and considered as valid if the result obtained match the trend of the previous data, regardless of minor difference in value. The expected result for my project is to clear and understand the concept of remanufacturing in the automotive industry, able to evaluate design for remanufacturing element variable and their desired value that lead to the sustainability. Then, model simulation using racing software able to be applied to evaluate the performance of real system for remanufacturing of car tire. And lastly, able to identify whether car tire remanufacturing should be implemented or otherwise in Malaysia. That's all from me. Thank you for listening to my final year project 1 with the title A System Dynamic Approach for Tire Remanufacturing.